So, good morning, good afternoon, or good evening, depending on where you are in the world. And welcome to this learning experience brought to you by StackState. My name is Cody, and welcome back to Techstrong Learning. We have an exciting panel ahead, but before we dive into things, I have just a couple of notes I'd like to review with you. First off, we are recording today's session. So if you happen to miss any of our discussion, if you'd like to rewatch, or if you'd like to share our conversation with the rest of your team, you will be receiving an email with a link to access our recording, and you'll get that shortly after we conclude our session today. Now, if you'd like to engage with us, there are a couple of ways to do so. The first option is the chat tab on the right side of your screen. So when you find that chat tab, I'd like you to let us know from where in the world you're joining us. I'm seeing Dallas, Colorado, New York City. I know we've got some global folks, so let us know there in the chat. Now, if you have any specific questions, we do want you to direct those to the Q&A, as that just helps us keep track of all of them, and we would like to answer as many questions as we can. Additionally, if you jump over to that handout section, you'll see that there are a couple of resources uploaded there for you, so feel free to grab those before we close things out today. And of course, we will be selecting 2 of our most engaged attendees to receive a $50 Amazon gift card. So be sure to send in your chats, your comments, your questions, and of course, take our survey at the end. So our topic is a deep dive into SaaS architectures and their observability approaches. I'm joined today by Siva Sadhu, Senior Partner Solution Architect at AWS, Andreas Prins, CEO at StackState, and we have our very own Mitch Ashley, CTO at Techstrong Group and GM of Techstrong Research. So thank you to Siva and Andreas coming to us live from their studio. But
thank you.
Mitch, would you like to lead us right into our conversation today?
You bet. Happy to, Cody. Thanks for the introduction, getting us started. I want to start out by introducing our panel, who are having our bulk of our conversation here, have them tell you a little bit about this. One thing before I do that is thank you everyone for sharing where you're joining us from. We have a great international audience. Thank you for folks where it's not work time, it's maybe into the day or night or whatever, wherever you are. Thank you for being here with us. We'd love for you to engage with us through that chat, and you're welcome. Share your thoughts, ideas, impressions. Hey, I liked what this person said, or hey, what about this? And you can, if you have a formal question, you can ask it via the Q&A tab. If you engage with us that way, we will incorporate that into the conversation too. So we're happy to have a conversation with you that way. So I think it's more engaging for all of us and just a lot more fun. So let's start out with introductions. We're joined today by Siva Sadhu with AWS, Andreas Prins, who is with StackState. Siva, would you introduce yourself first? Tell us a little bit about yourself, your background, kind of why we're talking about this topic today.
Thanks, Mitch. Thanks for having me on this webinar. I'm Siva Sadhu. I'm a Senior Partner Solutions Architect at AWS, working with technology partnerships. I focus on the startup segment in the EMEA region. I come with a background of software engineering. I started as a software developer, started building systems at scale, and then been an AWS customer for almost 6 years before jumping onto the other side. So have been building a lot of SaaS applications in my past career roles. And within AWS, I work with a lot of startup partners to build SaaS solutions and generate joint value for mutual customers.
Amazing. Fantastic. Well, it's good to be chatting with you, Andreas. We're talking about, it's been a few months since we've had a conversation together, and now we're doing with the 3 of us. So CEO of StackState, tell us a little bit about yourself and tell us about StackState too.
Yeah, definitely. Thanks. Always been in, or not always, in the last 7-8 years, always in product companies, really in the DevOps domain. I'm really in love with the DevOps domain, both the dev side, CI/CD, and other tools that are in the creation space as such. And in the recent years, I joined the observability space. I was always thinking that was the much easier part, that the development was the hardest part, but I actually learned in the last 2 years that running applications stable, reliable, cost efficient in production is kind of equally difficult. Leading the company since the last 9 months or something. It felt like 2 years, but a great experience as such. Born and raised in the Netherlands, but always been in these type of engagements and companies.
Fantastic. And it's been a little while now, but congratulations again on your leadership role of
Thank you.
StackState.
Thank
Wonderful.
you. And before you start, Mitch,
Mhm.
actually, when I was the people who joined, thanks for joining. They don't know how much we've been struggling to get at the minimum audio out. I don't know if it's decent audio, but we're running around until 1 minute past the hour. And that reminds me of systems, right, that run into trouble. And then all of a sudden the question is, how quickly can you bring it back on track and focus on the customer experience? Because that's what we're going to experience here today as well. So hopefully it works out really well.
Great analogy for what we're talking about, because we are using some SaaS services and
Exactly.
and working across the globe together. So great example. So we are talking about SaaS architecture, which kind of has its own domain of expertise and how you design applications, and observability in combination with that. Would love to have you, Siva, you've been doing this for a while. You've been engaging in this. Love to have you share some of your experiences as we've made this shift from just on-prem into also using SaaS applications.
For sure. When we talk about SaaS applications, and I would like to first start by saying the approach towards building or thinking about SaaS applications should be business first. It's a business approach that we are using technology as an enabler to solve that. So it's not just an architectural pattern, but it's an entire mindset and approach that enables software companies to onboard, to operate, and manage all of their customers, providing a unified experience for all of them. It should not be like each customer has a different experience. In case if customers require a different experience, the best practice that we talk about is to go through a customization, forego the customization process and make it configurable, so that the experience for all of the customers is going to be unique or uniform. So when we talk about uniform experiences and similar kind of approach for our customers, we bring in the concept of multi-tenancy. And when we talk about multi-tenant applications, the need for a more detailed operational view of the health of your systems, it is essential for the growth of a SaaS software company, or success of the SaaS software company. So that's what we're going to discuss today. How the observability aspect into SaaS applications is going to help software companies offering the products as a SaaS software as a service model be successful, grow successfully.
Cool.
Great. Any thoughts, Andreas?
Yeah. If I think about SaaS and a topic, or sorry, architectural patterns for SaaS and a topic like this, what is always intriguing to me is it's often taken from a more technical perspective. So yeah, engineers like to experiment with something, and we have already made a choice, so we will stick to that for the long term. I do think what is super important for businesses is really from a business perspective. What is actually the goal you would like to achieve with your business as a whole, or with the particular application that you are about to develop, and take a lot of considerations into account before you decide, hey, what is the architecture pattern? And really let it not just overcome, right? Not just it happens to me, but really plan for it and understand where to go. And I do think if we talk about architectures in SaaS, in cloud, whatever, there are really these two sides. So on one hand, there's the super technical aspect of it, but at the same time, there's the business angle and all the stuff that goes around. And I would really like to discover that today in this conversation.
Yeah, a really good point. You're building a SaaS application to serve a community, and there's always multi-tenancy is what we hear about typically with SaaS. I wish it was that simple. I'm guessing it's a lot more complex than that. We're going to hear about that.
Yeah.
So let's and we're starting out with the business kind of driver, why you're doing SaaS, the kind of services you want to offer, and of course, what that runway looks like as you build and grow the business. I have to imagine the architecture you pick to begin with is critical to help make sure you're not a year into this, you got to go rebuild it because you kind of went down the wrong path. Can you talk to us, Siva, about sort of the architectural patterns and why one approach fits different kinds of needs than others?
Sure. When we talk about the different models of SaaS environments of multi-tenant applications, we've come up with a terminology about how we describe what terminology we use to describe the different environments customers could be using to build SaaS applications. I'll start off with the silo model. One of the common thought process is that if you have shared infrastructure, you're SaaS. If you do not have shared infrastructure, you're not SaaS. That is not right. It is possible that you are not having shared infrastructure, you're having dedicated infrastructure to serve your customers, and you're still SaaS. So we'll look at three different terminology we can use to describe SaaS applications or the SaaS environments. The first one is the silo model, where each customer or each tenant in a multi-tenant system has their own set of infrastructure. We can see on the screen here an example of a web application and a couple of microservices that are serving those web application, which are deployed on dedicated infrastructure per customer, per tenant. And on the right side, we also have a pool infrastructure, which is all your infrastructure, all your services are shared for all your customers. Which is the right approach? A favorite answer is it depends. What are your business drivers? What are your business motivations? And what are it's influenced by different factors, which we'll talk about later. There is no there is no one size fits all approach. So we also talk about a bridge model where a certain set of components, a certain set of services are in a silo model, and some set of components could be in a pool model. So you get best of both the worlds. And this is what we see more realistically happening, that based on different business requirements or business drivers, customers are choosing to use purpose-built architectures that solve a particular business challenge. So we can use this terminology to describe various SaaS environments that we see customers building.
Yeah. And just to comment to that, because this is a really good point. What we see sometimes at customers is that the single customer. So when we do observability, a single customer can have all three flavors, even for a single application. So an example, the freemium model is in the pool, right? So it's a super small setup that they use, and it's pretty limited, so they can master that. Then as soon as it becomes a customer, they do kind of shared, the bridge model. So some services are making use of shared infrastructure. And then if they're highly secure customers and they really want to have their own instance, you almost move to the siloed model. And really what is intriguing me is that with the move of the architecture of the application, right, or the components that you want to land on your platform, it becomes extremely simple to pivot from one model to the other. If you take the underlying security and data segregation, obviously into account. But even for a single application, we see sometimes that multiple models are applied depending on the customer requirement or the customer size or the product you want to offer to lower the price, for example, if you talk about the freemium tier or a trial version or something like that. Do you recognize that, Siva?
Yeah, that's a good call out about tiering. Tiering has the greatest influence on which pattern to use. So that's a good approach to see freemium or the basic tier is on pool because they could share resources.
Yeah.
But as you tie it back to your business model where you want to add more premium services, or compliance is another reason.
Yeah.
Because customers in regulated industries want all of their compute and data separated, so you go towards the silo model.
Yeah.
Compliance, regional, requirements, regulations, data separation, locality, a lot of factors to consider, right?
Yeah.
I'm curious too, you're talking about microservices are in these three different architectural patterns. Can both of you talk a little bit about why microservices kind of fits this really well, a SaaS kind of application?
Well, I'll first talk about what microservices are, just to clarify that for the audience who might not know. Nowadays, I don't think there's anyone who doesn't know about microservices, but You take any software application that is composed of independent services that can be deployed separately, that are autonomous, that have boundaries defined by the business considerations. We consider them as part of microservice architecture. I mean, you can see on the screen, I have a couple of examples there when you talk about order microservice, product microservice. This is an example of an e-commerce application. So typical business groups there could be the product ordering service, where the actual transactions happen. It could be a product service, which is listing all the products in an e-commerce application. And there could be an invoicing team. There could be a shipping team. So each business unit has been identified and built using microservice architecture when the applications are built. So this gives the advantage of the agility and flexibility in choosing different kinds of technology components. Hey, I want to build this application in PHP. Hey, I want to build this application in Java or even Rust nowadays. You have that flexibility, and you have also have the ability to scale the services independently. So, depending on your traffic load, say there was a Black Friday sale recently. There was a lot of orders being placed by customers. So the order microservice has to scale. Where the shipping microservice, the shipping takes place after the fact later. So that may not scale as fast as the other microservice scales. So you have the flexibility to scale your application in different modes. And we see customers either building new software applications using the microservice pattern, or we also see refactoring, a lot of refactoring happening, existing legacy applications, modernizing them into a microservice architecture because we see the benefits that customers could reap out of it.
Yeah.
You also see that on the field.
Yeah, definitely. So you mentioned cost. Can I scale out and scale down particular components versus scaling out my entire application? There's also a piece of resilience in it. You didn't touch upon that, but if one piece fails, right, how easy can you restore that particular component? I do think that's an important one to take into account. The other part, which I do think is super important, is what are your deployment strategies? And if you talked about making teams autonomous, or give a team a responsibility, but it also allow you to start rolling out particular features or changes within that microservice much more independent from the other teams that are part of the bigger chain of your business offering. And I do think that resonates to agility, what you mentioned, but the deployment strategy, in my opinion, is 101 related, as well as the rollout strategies. So can you roll out multiple versions of your microservice? So it's not only when it is in production, but it's actually also the process going towards production where microservices strategies will benefit from compared to the more monolithic type of architectures, if you like. And then there's one aspect, Mitch, that I do think is really interesting, and a lot of people tend to forget. There's often not only a microservices set in a team or in a couple teams that work together, but what we really see happening often with e-commerce customers is, as an example, they rely on third-party services. Let's say you are an e-commerce, the shipping service, right, is from your local DHL or your UPS type of supplier, and often we tend to put system boundaries around, hey, this is what we have developed as a team. But thinking about a SaaS architecture or observability strategy for it, you should definitely take that bigger picture into account as well and really understand, hey, where do I rely on? Because they are equal part of the end-to-end chain that you need to observe and need to master.
Very good. One of our participants here asked a question. I think you could apply it to the three SaaS models as well as microservices architecture. That different approaches have different trade-offs, right? There's benefits to it. We've talked about agility and scalability and things like that. Cost is another factor. I think you've said that too. How do you weigh those factors in considering the approach you're going to take, both from an architectural pattern, and then do you deep dive into microservices? Do you take it kind of a modernization approach, a piece at a time?
Yeah.
Thoughts on that?
Yeah, there are two thoughts coming in my mind, and then Siva can give the other thoughts. Let's put it like this. So one thought is sometimes parts of your landscape, right, whether or not it's a microservice or just a technology component, are close to out of the box, ready for sharing, right? So ready for a decent pool, the right side of the image. So although potentially other microservices or other components of your landscape are not yet ready for that, for sharing, you could then decide that that particular component can be shared amongst multiple customers, multiple tenants, if you like. A good example is if you have a data bus, like whatever, Kafka, where you just put topics on and you take data from. Well, it's often relatively simple and easy to set up in a multi-tenant way. So why putting that in place for every tenant if you can make that a shared tenant? So sometimes there are technology considerations that make that relatively easy. Then the other consideration that comes into my mind straight away is how easy is it to make sure that the data is segregated from one tenant to the other. And if you come from a more classic approach and want to make that multi-tenant, you should really think through the compliance and the security aspect of your data if that's actually ready to make multi-tenant. So some components are kind of out of the box or easily turned into a shared model versus others who are not. Hey, and then you land ultimately in that middle model, the bridge, where you have some components shared and others are still, per tenant. So these are just the first thoughts coming into my mind. I don't know, what about you, Siva?
No, that's a good call out. Something else that comes to my mind is also the skill set of the teams, and how do you see if you have to transform an application? It could be you have a monolith shipping service. Now, if I have to transform this into microservices, it could take time. How it gives you agility. If that's something that would take 3 years to build. Well, you could start off, take an iterative approach. You could start off using the same shipping microservice for all customers, but it could also be in a silo model, which requires a high level of automation because you do not want to do this manually. Because in a SaaS model, we prefer customers do self-service onboarding. They are ready to use the application as soon as they sign up. And in that case, mature DevOps practices, we are definitely going to be a strong factor in deciding if your DevOps practices are mature, if you're able to automate the deployment process of that monolith, into different silos, or also if you're able to deploy it into different silos, you can move to the silo model. If you're not able to do that, which means that you have to use this application as a shared, when I say application, the shipping microservice, as a shared service for all of your customers, which means you need to have good observability into that application to ensure that all customers are getting the best performance out of it. One customer, we talk about the noisy neighbor problem. One customer is not blocking other customers from using it or not overloading that service. So I would also add in as part of your trade-offs, the mature DevOps practices and having the right observability strategy into your system.
Yeah, probably then one more to add is the question sometimes can be if you want to go fast or if you have not the right team skills or the right skills in your team, let's put it like this. Not microservicing everything, right, can also be a choice. If there's no money to earn, or if it's a stable workload, right, or if you're not expecting a lot of change in the near future, if the application runs already pretty stable for a supportive process in your organization, there's, in my opinion, not really a business driver that would push you to make that decision and invest money. Rather, take a look at your innovation, right, or the more customer-facing type of applications that do make you stand out in the field and make the changes over there. That also might have a cost impact. That's also related, I noticed, to the question. And sometimes if the workloads are super stable, the app is stable, not a lot of change is expected, don't touch it and focus on innovation.
It's a really good point. You don't want to take the what is it? Everything, everywhere, all at once. That movie. You're like, don't take all of it on. You may
Yeah.
be maturing or growing your microservices, but maybe you're really developing your DevOps now, and you could start to do microservices.
Yeah.
So that makes a big difference how much you take on.
Yeah, definitely.
Really good point. And you have constraints too. Sometimes we can't move that to microservices today, but here's strategies for helping us move that direction for parts of our application.
Yeah, and honestly, I don't know who was at KubeCon or AWS reInvent or any Kubernetes community days across the world. There are so many tools popping up around your application, infrastructure deployments, tools like Fleet, Argo CD. Well, I'm not calling them out all. But what is important there is the ecosystem these days starts to provide so many easy tools and instruments around managing applications or deploying applications or managing secrets or compliance or CI/CD, that the hurdles that probably were still in place 3 years ago or 5 years ago are also being taken away, right? Because the technology around your application is moving so fast with the innovation around Kubernetes and serverless, etc. So that's also something to, I would say, every other year. If you made a decision for a particular application, it won't last forever, right? Reassess if it can be about time to transition. So yeah, that was another thought.
A really good point, and I want to double emphasize that is I think one of the strengths of both StackState as a partner in the marketplace ecosystem with AWS. And I think of AWS not just as a cloud services provider, platform, et cetera. It really is an ecosystem, right? It's because both of your companies, are integrating not only with AWS, but also with other products and services. So if you've got a problem, I bet somebody there has solved it. You can go to Andreas, you can go to Siva and find out what's the next step on our path or give us some options. So it's huge. It's a huge advantage. Let's one of my favorite topics in addition to microservices is about how we use containers in a SaaS kind of strategy, maybe with, of course, throw a little bit of Kubernetes in there just to mix things up with the recipe. Talk a little bit about how containers apply into this kind of an architectural approach.
Yeah, definitely. We've at AWS, we've published some reference architectures on using Kubernetes or Amazon EKS, Elastic Kubernetes Service, to build SaaS applications using the container-based architectures. So, there are multiple choices. We see customers using, the Docker-based containers, deploy them on the Amazon Elastic Container Service. We also see customers using the Kubernetes ecosystem, build applications on Kubernetes, Kubernetes-based ecosystem, and deploy them on EKS. There are multiple approaches. So here we talk about how do we you build in the silo, going back to the silo, pool, and bridge-based architecture patterns using containers. And one of the approaches is, when you're on Kubernetes, you can use a namespace per tenant. Each tenant that you're serving would be in a Kubernetes namespace. As we can see on the slide here, we have the product and other microservices in individual namespaces. That is going with the silo model. And another approach is to have a tenant per cluster. So we can have a Kubernetes cluster or EKS cluster per tenant and serve customers as well. Similarly, if you're using the Docker ecosystem, you can have, when you're in ECS, you can have a service per customer or per tenant that you're serving. So there are various approaches, each of them, again, defined by different architecture choices and also defined upon, where you are in the maturity level in building different services on different container orchestrators. So we see these patterns that customers are using to build SaaS applications using the container-based architectures. Do you also see a lot of SaaS applications on Kubernetes,
Yeah,
containers.
definitely. And in this image, you made a kind of the horizontal slice. So a single tenant is replicated over multiple availability zones or a service, which is just a model. Classically, how we did it, right, with the data centers is you would have them all kind of in one, and then the other data center or availability zone would be the standby, right? Or you would spin them up, right, equal. So there are a lot of models possible. And I recently was listening, actually this morning, to a podcast about green ops, so reducing the carbon footprint. And the talk was about spotting data centers in Europe where there is green power. So often in summer months, right, you go deeper to the south. In winter, you go more to the Nordics because there are a lot of power plants based on water. I don't know the exact English word for that, but you get me. But the interesting part there is that you can, so there are multiple reasons on how you think about where do I actually deploy my workloads, in what region, etc. So that is something to take into the mix. Pricing or carbon footprint can be another one. The other thought coming into my mind straight away is if you think about an observability strategy, what is super important in this picture is that you not only observe your services that run into that particular availability zone, but it can be across multiple geographical locations that in total form a end-to-end service that you provide towards your customers. And I think if you see these type of architectural patterns, you should immediately ask yourself the question, how do I deploy towards all these availability zones and multiple tenants? That's one. But second, as soon as I have deployed it, how do I actually observe and visualize and build an understanding of how all the different tenants and services and lower resource workloads ultimately work together. And that is important because just bubbling up all information, I would say, in a Prometheus or Grafana dashboard doesn't do the trick to really visually understand how is my workload spread across and where is it failing and where do I need to take action. So that's another thought coming into my mind, the deployment as well as the observability of such a architecture.
Yeah, and there's also, I mean, this is spreading across availability zones. There's also one pattern that we see across multiple clusters. Tenants are deployed, and I was reading the blog series from StackState about multi-cluster observability. So I think definitely tooling like this helps customers gain more observability into the system, regardless of whatever pattern they use, whatever architecture pattern they use.
Yeah. And lately, just to call out a few, lately I was talking to a large bank, and they were setting up a new cloud platform, and where they primarily touched upon was kind of the cloud infra, the tools to get to that, to replicate that, to make that easy, make it compliant and make secure. And then I asked the question, obviously, the deployment and observability, and it was a kind of an afterthought. So, and I do think you should really take a kind of an end-to-end slice, right? It's platform, it's deployment, it's security, compliance, and observability versus first putting out the platform and then start to think about, but what if they start to deploy workloads? How do I manage that?
Very good. I want to throw a poll in here. Just we have some online polls. Get a feel for the audience, the folks that have joined us, the kind of roles that people are playing, and then we'll jump back into this. That might help us think about how we might talk about this for different roles and types. So take a minute, just select the best option for yourself, and we'll show the results here coming up in just a second. You know, one of my thoughts on this slide, there's a lot going on here, right? If you think about, so every one of those dotted lines is sort of one aspect of what we're talking about, whether it's the availability zones or, you know, and that could also be distribution for what you were talking about, Andreas, to take advantage of green ops and different locations, as well as, you know, VPC is how you're connecting into that. But the AWS auto scaling and how that happens across all of that. So I can imagine just thinking about trying to do that without a service like auto scaling has got to be quite complex. But there's a really good question I want to ask that came across from one of our participants. They were talking about asking about StackState solution. Do you offer a comprehensive single pane of glass type observability across these SaaS kind of environments? So maybe more generically, how would you think about observability and managing this, Andreas, from a StackState standpoint?
Yeah, that's a good question. The first aspect you need to think about is what are the facets that I want to observe. And observability, I imagine for most of us, the first element that comes into our mind is health, reliability, but not forget cost, compliance, and security, to call out the other one. So that's one. So think about all four of them rather than only application health or application reliability. The second portion is to ask, which is probably different than you normally ask, is who is involved. So what are the persona, what are the roles that are involved in utilizing this microservices platform or the EKS platform in this example? And why I'm calling that out is because often we tend to think about from a technical engineer for a technical engineer. And we tend to forget that often software developers who deploy towards the platform are absolutely not so deep in all the underlying things. So who am I setting up my observability? And these days, with developer experience and internal developer portals, I really think that is a good movement that I see in the market, where things like, hey, there are other roles utilizing my platform. What do they need? That is something to bring actually in the mix. So that's a second, probably strange consideration to think about. And then the third one is really, okay, but what is the foundation? If I want to have an observability strategy, what is the foundation that I want to put out there? And then you really need to think about the multitude of data sets or the different data sets that you actually need to build that holistic understanding. We talked about understanding what runs where, right? Dependency maps these days, or service dependency maps, but also think about your metrics, your events, your logs, but also just data coming, the config, the status, change information. So what is that rich data set that is required to provide that total picture? And then if you roll out the strategy, it's not only about having the data, but again, it's how do you make it possible for the regular developers or the SREs or the platform engineers to benefit from the data. So how do you build up your dashboards? What is the information you want to show? What are the signals you want to detect on, the thresholds, but also on the logs or the events? And ultimately, and that's often forgotten, is how do you remediate your issue? And in particular, and I'm calling that out because if you start scaling it out, a platform like this to all your engineering teams, the knowledge resides often at your platform engineers or your SREs, but how do you encapsulate that in Notion pages or Confluence, or even in a tool like StackState with runbooks or playbooks or remediation guides? So don't think about, hey, I have dashboards and threshold set alerts. That's about it. How do you remediate? That's probably the most important element to add into your observability mix or into your observability strategy.
Wonderful. One of the things I've learned is you can tell who drew the diagram by what's in the middle, the center of it. If it's a cloud or security or software person, if you can't tell, an architect drew it. So, Siva, we know this is from you.
I never heard that. That's
it's
a good
not
one.
a jab. That's a compliment. So, I do want to just share real quick. I'll kind of read these out instead of popping it up. Let's see here. The results of the poll that we just did. About 34% were in leadership role, and then the other kind of roles that people were in, a pretty good mix of site reliability engineer and DevOps engineer, then some platform engineering. We didn't have a lot of software developers respond on that, but it sounds like we're kind of targeting infrastructure folks that are oriented that way, which makes sense from an architectural standpoint. To your point earlier, Andreas, about software developers may not see all of this, right?
Yeah.
Some of this will look like plumbing to them or things that other people do.
Yeah. But the fascinating part and what we've learned from our customers is often the issues that arise are in the interaction between the application and the underlying infrastructure. So the infrastructure with Kubernetes and OpenShift and whatever, auto healing and auto scaling, right? That is pretty okay, but it's often the interaction, just a stupid misconfiguration or a deployment that went wrong, or a rollout strategy, or an interaction with another microservice that was broken, or security group that changed. So it's often that interaction between the two layers that is causing the issue. So yeah, I do think software developers are utilizing it a lot, but not necessarily configuring and building it.
Well, let's go kind of to another element of cloud native architectures, and that's around serverless architecture and where that might apply.
We still do see the polling question, Mitch. I don't know if...
Oh, do we? Okay, let me pull that down here. Or Cody, could you pull that down for me?
It's gone. Perfect.
Okay, great, thanks. Siva, you want to talk about serverless?
Definitely. As part of application modernization, we also see customers building their applications, specifically SaaS applications, again, using the serverless architecture model as well. And as I mentioned earlier, we also published as part of AWS SaaS Factory reference architectures, and also some cool workshops around this. So we see that, with the serverless architecture pattern, when you have, traffic patterns that are not predictable, or when you want to instantly scale, when you don't want to run your applications 24/7 because they might not be used always. Going the serverless way is ideal in terms of giving you that flexibility, giving you that agility, giving you that cost optimization. And again, tying back to the initial mental model of pool, silo, and bridge, we see a similar kind of architecture pattern that customers are using to build if SaaS applications. So, on a pooled model, they have a set of services, as you can see on the screen here: AppSync, Lambda, and DynamoDB. Typically, a GraphQL application which is backed by Lambda and database stored in DynamoDB. All of these are serverless, fully managed services on a pay-as-you-go model. So when all of these are shared across all your tenants or your customers, that's the pool model. On the silo model, again, for each tenant, you deploy a set of these services. On a bridge model, again, you have, for a few tenants or a few services, you use this architecture, and for some other tenants or services, you use a silo model. So you make a combination of both to get the best of both worlds. And do you also see customers using serverless architecture patterns often?
No, not so often. We do see it, definitely. We do see it in the islands of innovation. So the teams that are already far in other practices, the CI/CD practices, GitOps, security and compliance, they are brave enough to start. I do think kind of on the next level of architecture. That's where we see it. But in general, I do think there's still a big move going to the cloud in general, right? With microservices, or even making it more microservice based. And then serverless, to me, is really in the islands of innovation where you need the flexibility of infrastructure, speed up rather quickly and slim it down, than not having that. However, what it triggered with a couple of our customers is when doing so, where I would say observability differs a little bit, and that was a surprise to me a couple of years ago, is they really need it in the dev environments. Because when developing this, with functions coming and going, not knowing what communicates with what, they actually needed to have that insight in development more than having it in production. Because if it works, it will just work, right? It scales out up and down super easily. But in the development, what talks to what? Is it actually well established? So the observability tool, well, they used StackState, but the observability tool was more almost a dev tool to understand, hey, how do my functions, my lambdas communicate with each other than it was for production as such. So that was kind of a surprise to me.
Okay. Well, that's interesting. I mean, even in production workloads, definitely observability, observing the serverless applications has a key role, because it just gives you good insights into how each of the components, each of the services used to build your serverless architecture performing. As we commonly hear from our CTO, everything fails all the time. So it could be a Lambda function that has failed, and downstream something could be impacted. So it's definitely useful in production also to understand the landscape. And you're right, we see customers using serverless architecture not just use an AppSync and Lambda. They could be sometimes even hundreds of Lambda functions they could be using to achieve a particular functionality. Use step functions to orchestrate all of these. So when they're using these multiple services, more number of components, functions running on AWS Lambda, it's important that they know that which one of them has failed, and that gives immediate visibility into what could affect downstream. Especially if they're in a pooled architecture, it could impact thousands of customers.
Let's turn the tables to talk about observability. Of course, this is Andreas's favorite topic, but I know Siva, I mean, to your earlier point, like, I don't know how you do serverless, and more or less microservices-based architecture without it. If you want to go to the next slide, observability and SaaS. You want to make a few comments about this, Siva? And I really would like to give you the floor to you, Andreas, to talk about this.
Yeah, when I think about observability in SaaS applications, it's important to call out three key things here. From a business perspective, you provide as a SaaS vendor, because you run and operate the application in a SaaS model. So you provide SLA guarantees to your customers that, hey, the application will be up and running for 99.59% of the time, or whatever guarantees that you get. As I was just talking about in the serverless example, it's important also to detect any issues early on and remediate them so that there is a minimal impact on your customers. Specifically, I'm talking about this in the SaaS model because you have the responsibility to operate the applications for your customers. You also have the possibility that, say you're using a pool model for a set of services, a small issue can impact not one customer, but thousands or even tens of thousands of your customers. And again, tying back to business, because when we talk about SaaS applications, we talk about consumption-based pricing, different pricing tiers. It's important to understand your usage patterns of your customers, how they're using a particular API. Are they using it more than you expect, less than you expect? As you iterate, as you innovate, you would want to know about usage patterns of your customers. And tie this back to your pricing tiers. You could start with 3 pricing tiers, but you see that customers are using a particular API, a particular component of your pricing tier, a number of files that store on your system, for example. There's more demand for this, and you would know that only when you have a right, well-defined observability strategy. You could tie this back to your pricing tier and optimize your pricing tier, and continuously update it. It's not just I have defined this pricing tier; it's going to stay on for life, but you use data and make data-driven decisions to continuously optimize your pricing model, pricing tiers. And
then if you speak about the pricing tier, you mean, imagine I'm running a business and I offer services to my end customers, and particular components are used more than others, right? So they cost me more to operate.
Your operating cost,
right? You reconsider the pricing you put at the customer, right? And take portions out or make a premium or whatever you do, or price that component higher, or shorter data retention or whatever.
Maybe the customer wants it, so you can have a dedicated silo tier for that customer.
Exactly.
With a different pricing model.
So
it helps you innovate. It helps you enhance your offering continuously.
That's an interesting one. Versus the ultimate extreme, a monolith, where you all the time need to scale out that entire beast, right? And cannot tune it for particular pieces of your functionality or capability used by the customer. That's an interesting one. I never thought about that. Yeah, it's a good one.
And you pointed about rightly about optimizing your operating cost. And when you have these insights through the right observability strategy in your system, you optimize your operating cost as well. Because sometimes you started off and you see your customers in your free tier have higher operating cost, and customers in your premium tier have a lower operating cost, which is not good for your business.
No, I know.
So you want to turn it around, and that's when you would get with the right insights, you could turn it around and keep continuously optimizing your operating cost as well. Because especially in the current environment, you would want to lower those operating costs continuously. And I specifically wanted to also point out something that we heard at reInvent from Amazon CTO Monolith Vogels, is to build cost-aware architectures. And he also introduced the concept of frugal architectures. And one of the things that he mentioned when he spoke about frugal architectures, his website was launched. I don't know if it's clearly visible. There's law 4 there, which says unobserved systems lead to unknown costs. Without careful observation and measurement, the true cost of a system remain invisible. So it's important to have the right observability strategy, observe your system completely and comprehensively to optimize for cost as well and be frugal.
Yeah, interesting. If I think about cost optimization, it's obviously for my build, but I don't think that often. What if I split it, or if I charge particular components more straight to the user? Can you go back to the previous slide? Because you're calling out a couple really good points, and I'm not going to repeat. I do want to emphasize, however, the first bullet, the SLA guarantees, because if you think about an observability strategy, when is enough from a reliability perspective? When do you stop investing in improving the reliability? And it's the same question as what is quality, right? You need to make that super specific. And often I do see a lot of teams just making dashboards and putting alerts out in OpsGenie or PagerDuty, but they tend to forget to articulate what really matters. So thinking in SLIs, service level indicators, and SLAs, what is it that is a kind of that I want to manage in my 30-day period, I do think is super important. And then you are really a master if you're able to tie that together with your SLOs. The objectives, and tie that together with your SLAs, the more business-oriented type of statements. So thinking that through, and there are quite a bit of leaders in this role, I would really challenge you to go to your engineering teams and have the conversation on particular the service level objectives, because I do think that is super important to know where to focus on and what to build. I've mentioned already a lot of topics in my earlier replies. What is also, I do think, an important one is performance degradation or optimization in general from your application, because often with an observability strategy, we tend to focus on the black swans, the big issues, outages, big disruptions. But what is really important to focus on as well is to take into account, but what about my continuous performance degradation? Imagine you're deploying every other day or every week, and slowly over time, that microservice becomes less performant. Well, you don't notice it from one to the other, but in the long run, your latency, customer experience will get much worse. So thinking that through and having tools that support you with that, I do think is really important. And that goes hand in hand with the broader site reliability engineering process or practices, if you like. The process, how do you remediate an issue as fast as possible? And the book gives a really good process there. So how do you triage, examine, diagnose the entire thing? And is your observability solution suitable to support you there? And the second part is just the generic developer practices to apply for reliable and performant applications. And I do think that is important to take that into account from a performance and observability strategy as well. You're muted, Mitch. Sorry.
There we go. My mic got muted. We have a few minutes left, and I want to jump to key considerations for observability. Also want to point folks to the handout, if that's the right point. Handout section, there's a couple of really great guides, troubleshooting, great guides to Kubernetes too, that StackState's put together. So be sure and check those out. Okay, you want to take first crack at this, Andreas?
Yeah. So pointed out here a couple key considerations if you think about observability, and really important is start upfront by thinking through your observability strategy. So what is it that you need to instrument? Your tenant, your application, use libraries like OpenTelemetry to use these type of things. But also, if you remember the architecture pattern or picture, how do you get ultimately the data into your observability hub or whatever platform tool that you use. I do think that's really important. The second one is if you think about a business offering with multiple customers, you need to be able to master and observe that big picture, right? How are my customers doing? That's actually a roll-up, if you like, of the distinct signals from the distinct tenants that form your entire customer population, but have that overall view, as well as have the ability to pretty quickly drill down real deeply all the way down to your infrastructure and your data center. So being able to navigate that left to right between tenants and top to bottom from a tenant deep down into, hey, what is actually causing it? That is a second consideration. And then the other one, in particular, if you start sharing infrastructure, think about the impact from your noisy neighbors onto the tenants that you're looking at and that you're observing. So is your observability strategy or your tool that you're using aware of that more complex intertwined infrastructure usage and probably even components usage that you need to cover? And what we see at our customers that helps tremendously is that rich dependency map. So knowing how all resources are connected to each other, we think is really the foundation to start managing complex workloads and complex environments, multi-tenant, siloed, bridged, whatever pattern that you pick.
Great. Siva, final thoughts on this before we wrap up?
Yeah, we've been talking about different roles. We also had a poll about which roles have joined this webinar today, but a role that hasn't been enough spoken about is the customer success or the support role, who are key customer facing roles. And building this kind of having a clearly defined comprehensive observability strategy, specifically in SaaS applications, building this kind of operational views. We also help your support teams, customer success teams, to drill down into hey, this tenant has reached out to me that something is wrong with their tenant, whatever product that they're using, and having this kind of view will help enable the support teams, help them in looking into tenant specific information. So I would want to close this by saying, ensure that tenant context is propagated all throughout the system. It's available everywhere, so that using tools like StackState, you can drill down into tenant-specific operational views.
Very good. Well, before I hand it back over to Cody to close things out, Siva Sadhu, Senior Partner Solutions Architect with AWS, Andreas Prins with CEO with StackState. Thank you to you both. I wish we had one of those after the shows, like on the streaming services. You join for the other questions that we.
Yeah.
We'll have to figure out how to do that sometime, but we could go another hour. I really appreciate you both sharing so much in this short period of time with everyone. Thanks, guys.
Thanks for having us.
Back to you in the control booth there, Cody.
Awesome. Thank you so much, Mitch. And once again, thank you to Siva and Andreas. It's always such a good time having StackState on with us. And so we appreciate you guys joining us on Techstrong Learning. Just one quick reminder to our audience, a couple quick reminders. We have been recording our session today, so you will be receiving that recording via email here shortly as soon as it's available. But you can also catch the recording on devops.com/webinars, and it will be in the on-demand section. The two winners of our $50 gift card giveaway will be contacted here shortly, and we will be selecting from those who have filled out our survey and sent in questions, thoughts throughout our program. So it's not too late to fill out that survey for us. It is there in the chat section. I'd like to thank StackState for sponsoring our program. And to our audience, thank you so much for joining us for the entirety of our program today. We appreciate your time, and we hope to see you at a future Techstrong Learning experience. Have a great rest of your day, and you may now disconnect.
Amazing. Thanks a lot.
Thank you.